Okay, here's a problem from 1994 under the category Areas and Volumes. Rectangle ABCD has an area of 21 square feet. Isosceles trapezoid ABQP has bases AB and PQ in a ratio of 7 to 3 respectively. If AP equals 4 feet, find the longest possible length of AD. Express answer to the nearest thousandth. So, they give us a diagram, and let's mark some length. So on the base, let's call this length 7x. And since AB is in a ratio of 7 to 3 with PQ, we can write that PQ equals 3x. So, also, since this is an isosceles trapezoid, it's symmetrical, meaning these two lengths are the same. And they have to be 2x each, because all these lengths have to add up to 7x. So that makes sense. 2x plus 3x plus 2x is 7x. But we don't know the height of this rectangle, so we'll just call it A. But what we do know is the area of the triangle, which is 21. And that's equal to the base times the height equals 7x times A. And from this we write 21 over 7x equals A, and that means 3 over x. So now that we have a value for A, we need to solve for x. So let's redraw one of these triangles. This triangle, let's draw it over here. So it's a right triangle, and whenever we see a right triangle, we just use the Pythagorean theorem. Actually, let me show my work. And that gives us 9 over x squared plus 4x squared equals 16. And this is normally hard to solve, but if we let u equal x squared, we can rewrite this as 9 over u plus 4u equals 16. And if we multiply this whole equation by u, we get 9 plus 4u squared equals 16u. And this is just a quadratic, so we'll just rewrite it as 4u squared minus 16u plus 9 equals 0. And sadly, this you can't just factor it. You have to use the quadratic formula. So let's write the equation. And this gives us values of u is approximately equal to and since u equals x squared, x is equal to square root of u. And we're only looking at the positive square root since x can only be positive. And that gives us okay, so now we have two values for x. But the length of AD equals A if we look at the diagram. this length is AD, and we called it A. And the problem wants us to find the longest possible length of AD. So, and that's 3 over x. So we want to find the lowest possible value for x, and that's right here. And so A, if we use the lowest possible value of x, would equal and that's around equal to 3.646. So, and that turns out to be the answer. So how we did this problem by finding A in terms of x, which was an arbitrary value we assigned to the base of the trapezoid. And then once we find A in terms of x, we can use a system of equations to solve for different values of x that could work, and then we have to find the value of x that would maximize A, because that's what the problem wants. And the maximized value of A is 3.646.